Guys, let's do this problem right here. The question is asking to find eigenvalues and find eigenvalues, find eigenvectors, find basis for each eigenspace, and the D part is find algebraic and geometric multiplies for eigenvalues, and is it diagnosable, find P and D, and also find a power 20. So let's see how we can do this. So first of all, find eigenvalues. So to find eigenvalue, what we have to do is we have to set this equation, right? So set this equation to determinant a minus lambda I is equal to 0. So that's the first thing we have to do. So in this case, this is a 2 by 2 matrix, and for 2 by 2 matrix, lambda is going to be something like this. First of all, identity is going to be something like this, right? 1 0 0 1, and if you multiply this one by lambda, this is going to be lambda 0 0 lambda. So this is the multiplication of lambda I. In this case, we are subtracting this from a. So the thing is, it's going to be something like this: 1 minus lambda, then 2, 2, and 4 minus lambda. Because the lambdas are only in the diagonal, so when you substitute, it's going to only subtract the diagonals, right? This is equal to 0. Then I have to find the determinant, so it's going to be AD minus BC. It says this multiplication minus this, so it's going to be 1 minus lambda times 4 minus lambda minus 4 is equal to 0. So if I multiply this one, it's going to become 4, and if I multiply this one, it's going to be negative lambda, and this is going to be minus 4 lambda, and plus lambda square minus 4 is equal to 0. Now I rearrange and solve. So I can cancel this 4 and 4, and if I rearrange this one, I will get lambda square and minus lambda minus 4 lambda is going to be minus 5 lambda is equal to 0, and I can take the lambda common. If I take the lambda common, it's going to be lambda minus 5 is equal to 0. Therefore, there are two eigenvalues. One of them is going to be lambda is equal to 0. Other one is going to be lambda is equal to 5. So these are my two eigenvalues. And the next question is asking find eigenvectors. So to find the eigenvectors, what I have to do is I have to grab this equation and set it to null space. So that's the general thing we do in the eigenvectors. So in this case, I take this lambda is equal to 0 first. So first of all, I write the general equation. So it's going to be so a minus lambda I is equal to 0. So this is null space. In this case, I'm copying this one. So 1 minus lambda 2 4 minus lambda equal to 0. So that's what we are going to do. Or you can write it as this is okay. So 1 minus lambda 2 4 minus lambda, we have to write it in matrix format, so this is going to be 0 0 like this. Then what I have to do is I have to simply substitute. So first I take the lambda is equal to 0 value. So if I take this one and if I substitute here, it's going to be just same as it is, because 0 doesn't change anything. So it's only 1 2 2 4 equal to 0 0. And if you see, this is multiplication of this. Therefore, if I can get rid of this one, because if you do the Gauss theorem, you will get rid of this. So it will become 1 2 0 and 0 0 0, and therefore my answer is going to be x plus 2y is equal to 0. Therefore x is going to be equal to minus 2y. Therefore vectors, eigenvectors, vectors are is going to be equal to minus 2y comma y, and if I take the y common, it's going to be minus 2 comma 1, and I can write this one as span of minus 2 1. So this is the first eigenvectors. And to find this eigenvectors for lambda is equal to 5, lambda is equal to 5, what I have to do is I have to simply substitute this 5 for this lambda. So it's going to be 1 minus 5 2 2 4 minus 5, and if I find the values, so this is I'm setting this to null space. So 1 minus 4 is going to be minus 4, 2 2 minus 1. Then I'm setting this one into null space, and if you see, if I multiply this one by 2 and add to this one is 0, right? So therefore this is linearly dependent. So we can get rid of this one of this. I swap this the bottom one on top because this is simplest form. So that's what we want. So 2 minus 1, and if I multiply this one by 2 and add it to the other one, it's going to be 0. So I put the 0 here. So we are doing the Gauss theorem. So in this case, to do the Gauss theorem fully, I had to divide this one by 2 because we want the 1 as a pivot. So in this case, if I divide this one by 2, I will get 1 minus 1 by 2, 0, 0, 0, 0. Therefore, x is going to be equal to x minus half y is equal to 0. Therefore, x is equal to half y. Therefore, eigenvectors are equal to half y comma y. Therefore, my answer is going to be y. If I take y common, half comma 1, and I can write this one as span of half 1. So these are my eigenvectors. Then the C part is asking find a basis for each eigenspace. So basis is going to be simply the vectors. So C part, you can say for lambda is equal to 0, b is equal to, what is that, minus 2 and 1. So b is equal to minus 2 comma 1. For lambda is equal to 5, b is going to be equal to half comma 1. And then they are asking for the algebraic and the geometric multiplication. So basically algebraic multiplication means so when we factor this one, the power of each. So in this case, if we have square, that's mean algebraic multiplication of 2. But in this case, we only like the final factor form. It's only one power, right? So therefore, both of them are algebraic multiplication of 1. So we can say each eigenvalue. So lambda is equal to 5. Algebraic multiplication is 1. And geometric multiplication is basically the free variable. So in this case, for lambda is equal to 5, we only have one free variable, therefore that's also 1. So geometric multiplication is also equal to 1. And for lambda is equal to 0, same thing, because if you see that's the only power 1, so it's going to be algebraic multiplication is going to be simply 1. And geometric multiplication also 1, because it's only a one free variable. So this is the answer for D. And E is asking is it diagonalizable. So how to determine diagonalizable? It's basically if you have algebraic multiplication and geometric multiplication are equal numbers. For example, this is 1 1. What happens if in case we have 2 2? Still diagonalizable, because we want for each eigenvalue should be equal number. So it doesn't matter what number. For example, if we have 2 and 1, then it's not diagonalizable. But if we have 2 2 here and 1 1 here, that's diagonalizable. So in this case, this is diagonalizable because both of the eigenvalues have same numbers. So diagonalizable. That's E part. And the F part is asking find the matrices P and D such that P minus P inverse AP is equal to T. And let's see how we can find it. So F is going to be, so P is basically the eigenvectors that we put here in the basis, right? Same thing. So P is, you have to arrange like minus 2, 1, and this is going to be half 1. But in this case, yeah, half, you can take half 1, and this is my P. Therefore, my D should be equal to, it should be respect the order of this one. So in this case, minus 2, 1. This belongs to lambda is equal to 0, right? When eigenvalue lambda is equal to 0 is the like vector for this one is minus 2 and 1. Therefore, this should be the first one. In case if you put half and 1, then this should be 5. But in this case, we put the eigenvalue of 0 first. Therefore, we put 0 here. And for the next one, half and 1, that's for lambda is equal to 5. So I had to put the 5 here, and others are going to be 0. So that's how we do. In case if you put half 1 here, the 5 come here, and if you write minus 2 1, the 0 goes to the bottom. So that's how we do this D part. Then they are asking to find A20. So let's see how we can do this. A20, so basically we grab this equation, T inverse AP is equal to D. So what we have to do is, since they are asking for A20, we have to get rid of this P here. So to get rid of this one, what I have to do is, get rid of this one, I have to multiply this one by P. So P times P inverse A and P. To get rid of this P, I have to multiply this one by P inverse. But if I multiply this side by this one, I have to multiply the other side too. So in this case, if I multiply P from the left side, so I have to multiply the P from the left side here, the other side. And I multiply this one P inverse from the right side. I have to multiply other side P inverse from the right side. So if I do that one, this one will be cancelled. Therefore, the final will be A is equal to P D P inverse. But they are asking for the 20, right? So in this case, what's going to happen is A power 20 is equal to P power P times D power 20. Remember, D is the only the one gonna give the power. So D power 20 and P inverse. Therefore, we can say A power 20, right? So A power 20 is going to be equal to P. We know the P here. Minus 2, 1, half, 1 times D. So this is 0 power 20, it's going to be 0. Then 5 power 20, here 0, 0, multiply by P inverse. So it's going to be, since I don't have enough space, I just write here, okay, it's minus 2 half 1 1 inverse. So you have to find the inverse. You can use the Gauss showdown or 1 over AD minus BC method to find the inverse. So there are two ways to find it. So you can find the inverse, and that's going to be the final answer. If you multiply them, you will get the final answer. And that's how it's done. I hope you guys like this video. See you next time.